Hey everybody, Bones here, Bones Garage, just bringing you an update what's going on at the garage. So the other day, we were showing you the motor that these heads came off of, this head and this head. I was explaining to you why these rockers were so worn out. They shouldn't have been that worn out. Look at, every one of them is worn out. That one was the worst one. This one was really, really bad as well. So every single rocker has bad wear on it. Every single one of them. They all have valleys and gaps, and I mean, it's just pretty much terrible. There's another one. Look at how bad they are. They should not have that cut into them right there. This should be really nice and smooth. This is one of the best ones right here. How nice and smooth that is. That's the way it should look. It even has a pretty bad ridge right over here, but look at how far in it went on this one. So I'm going to explain to you now why those look like they do. First reason, his push rods were way too short. These are a 7.8. That's how long these push rods are. They are too short. He should have been an 8.2, somewhere around there. So 8.2 inches long is what he should have had at minimum. Maybe even 8.3 would have worked. But these were way too short. So the end of the rocker was not sitting nicely on the end of the valve tip. That is what's causing all of this to happen, because these are really soft. These are really hard. So this is what's going to wear out. That's not going to wear out nearly as fast. Now, these valves sit in the combustion chamber at the head. This is your combustion chamber right here. The piston comes up, compresses the fuel-air mixture. The spark plug, which sits right over here, ignites the fuel-air mixture. The piston goes back down. This valve is an exhaust valve. This is a 1.6 exhaust valve. In other words, it's 1.6 inches in diameter. This is your intake valve. It is a 202 intake valve, which is 2.02 inches in diameter. A little bit bigger than stock. Not by much, but enough to make a difference. This valve would sit right in there, and it goes into the valve guide, which is a bronze guide, and sits there against the seat like that. That's how they sit. When you come to this side, there is the end of the valve. Valve goes up and down, opens to let the burnt fuel air mixture out, closes to assist in combustion, to keep all the combustion inside this chamber here. The spring, this is your spring, would sit right here. This is a retainer, and then you have a lower retainer. These are the wrong lower retainers, and these are a much too heavy spring. These springs, you need 175 pounds to push this spring to have it hold this valve closed. As you push the valve open, the rate of the spring increases. So enough pressure, the amount of pressure you need to push this down increases as you go further and further down. This is a double spring. It's an anti-float spring. That's what these are called. These are anti-float springs. These are way too heavy for what we have in the motor of the car these heads came off of. We have a flat tappet cam with a little bit higher than stock profile on the camshaft. One day I'll do another video on camshafts. What is happening is, as the valve is going down, as the spring is being pushed, it is being pushed very hard, way harder than it needed to be. These shims were not made to take that kind of pressure. And if you look at that shim, see that slot right there? That slot should not be there. This shim is to be used to make all of your valves sit at the same pressure. And no matter where or what valve is opening, they open and close with the same amount of pressure. It keeps for a nice, steady valve train, which makes the motor run much smoother, much better. Now, with these being the way they are, and they not being what was supposed to be there, you can see there's another one. Every one of them has it. You can see that there. This one is a thicker shim, which again shouldn't be down there, but it's a much better shim to be using, or a lower retainer. What was happening is, look at how the valve spring is eating into the seat of the spring, the valve spring seat. It is eating into it. This is only after a few thousand miles on this car. This motor does not have a lot of miles on it. This is your bronze valve guide. This goes there. Then your valve seal goes on top of the guide like that, and your valve pokes through that. This seal keeps the oil from going into the valve and then into the cylinder, which is when people say you're burning oil. Usually it's either coming from there or it's coming from worn out rings, which are on the piston. And we could do that another day. So we take that off, and that's what's going on with this head. Everything that they did on this valve train setup was done wrong. They actually, basically they ruined these heads. These are not a very expensive head. They're probably about $500 to $600 per head, which isn't really expensive. But they are ruined, because by the time I get them to a machinist, he cuts these all down. Now they have to be approximately the same height, each one of these. By the time he gets them all cut down, we get the head back, we shim them to get the proper height on the valve spring, so each valve spring opens at the same and closes at the same rate and holds the valve closed at the same rate, spring rate that is, whatever the pressures are. It is going to be way more money than what the actual head is worth. Can these be used again? Yeah, we could probably get a better retainer for these, a lower retainer, and just stick them right on top, put it all together, and throw it on just about any motor. But if you want it to last, that's not the way to do it. That is not a good setup, and I will not do that for somebody. If that's what they want me to do, they could take this and go somewhere else and get it done by them, because I am not going to be responsible for what happens there. Another thing, they have a non-adjustable push rod guide. They're good, they work, I have nothing against them. I just prefer an adjustable push rod guide, because you can then angle your rocker arm to sit properly on the top of the valve stem. So you could take your rocker arm and you could move it back and forth. And if we go on this side of the shop, I have a brand new set of heads. Yes! And you win a brand new set of heads, all painted and ready to go. We taped them all off. We got them all painted. They're all ready to go in. I bought the heads. I bought the springs. These are a 115 spring. So in other words, their spring rate is 115 pounds of closed pressure. So the valve, the pressure on the valve closed is 115 pounds. It's a 10-degree keeper on a 10-degree retainer with a nice thick retainer, rather than those really heavy springs that are in those heads over there. We also went to a 7/16 stud as opposed to the old 3/8 stud, and then we went with the adjustable guides, which are really nice. I really like having the adjustable guides. Some people are going to say that's garbage, they blah, blah, blah. I like them. I think they work nicely. You could move them back and forth, and you can get your rocker nicely centered. Look at how nice and centered. That right there, that little wear on the die that I put on top of the valve stem is perfectly centered from bottom to top and side to side. It is perfectly centered on there. Because as these rockers, this is the old style rocker, this is the new style rocker, which is a full roller rocker. It's got a center trunnion rocker, a center trunnion roller on the rocker, and at the tip, it has a tip that's a roller. This is a little roller right here. As the rocker moves up and down, and I'll show you right here, as the rocker moves up and down, it moves in an arc. Anytime you hold one section still and move something up and down, it moves in an arc. Now, with that arc, you have to get it perfectly centered on your valve tip. So this will sit right here like that. Your push rod will sit right in there like that. Now it would sit on this side, and the tip right here will sit in that little crevice right there, that little divot right there, just like that. As the cam rotates, it hits a lobe, pushes the push rod upward. The push rod then takes the rocker and makes the rocker go downwards. So it pushes this end up, that end down. As it goes up and down, it's going to slide back and forth on the valve tip. My job is to get these to center the rocker this way, and to get these to center the rocker this way, front to back, like that. So side to side with these, front to back with these. And this means this push rod has to be the exact right length to the 100th of a point or a decimal. So it takes time to get all of this done, which is something that they did not do when they put those heads together. They probably went somewhere, bought a set of heads, bought a set of springs, threw them together, had some stock rocker arms laying around with some stock, because this is a stock push rod, laying around, and just threw the whole thing together. You can't do it that way. You have to measure everything. Everything has to be measured. And as you can see, I do 3 at least of the valves before I say that, yes, I need a 7.8 inch push rod. This is a 7.8 inch push rod. But the problem is, this rocker, if you look where the divot is here, and where the divot is here, and where the trunnion is to where the bottom of the rocker here is, you need a much longer push rod. You need a push rod that's going to be 8.2 inches, 8.3 inches long to work with this rocker, these springs, and this aluminum head, because aluminum heads are thicker than the cast steel heads. So there's a lot of differences that you have to take into consideration, and a lot of things that you do also have to take into consideration. You also have to think about how steady all of this is going to be. Remember, these things are vibrating up and down. At an idle, you can barely tell. You can barely see them going up and down. You can't count how many times they go up and down. That's how fast they're moving at an idle, which is only, say, anywhere from 600 to 1200 RPM on most street cars. So that's at an idle. When you start hitting 5,800 RPM, well, this thing is moving hugely, huge amounts, and speed, so fast up and down. As the rollers in here, they will cause a whole lot less friction, a whole lot less heat. Also, the rollers in here will do the same. Whereas the little ball pivot that sits in here, which actually rubs back and forth in here, cause a lot of friction and a lot of heat and a lot of wear, along with the tip, which rubs back and forth on the valve tip. A lot of friction, a lot of heat, a lot of wear. So there is a lot that goes into buying a set of heads and in getting everything correct. Even when we turn these over, you will see, let's get it there. This is actually, I got it with a smaller combustion chamber, which is going to bring our compression up higher. That combustion chamber there is a 72cc combustion chamber. This is a 64cc combustion chamber. We still have the 2.02 intake valve and the 1.6 exhaust valve, but we have a smaller, and you can notice by right here how much smaller they are. The spark plug sits right over here, and it sticks out right over to about there, and then the combustion happens within this chamber. And that's where the start is, and then it pushes down the piston. It's not an explosion. An explosion is something that happens outside of something. Combustion is something that happens inside of a chamber. That is what a piston, cylinder, and head are. They make up a chamber. So there you go. Quick little thing on heads. There is so much more you can get into. There is so many things you can talk about on just heads and airflow. And these are 180cc intakes on this head. So the amount of space in here will fill 180 cc's. So you can put 180 cc's of alcohol or water or something like that inside of this chamber right here. So that's 180 cc head. Is it the best head in the world? No. This is not bottom, but it's really close to it. Are they great valves? No, they're nice valves. But this will work really nicely on the street. It is not meant for huge RPMs. It is not meant for extreme high compression. It is not meant for really high, really long lift and duration cams. It is meant as a street car that you can go out. If you want to do a couple of burnouts, perfect. They will work absolutely. They will flow enough air, flow enough fuel, flow enough exhaust to do that. And in here, you can also look into the exhaust port. It's so cool. Look into the exhaust port and see the valve stem right over there. See? There's the valve stem. There's your bronze guide right there. So that's the bottom side of up here. So there you go. Long video, gonna have to put it up in a whole bunch of different pieces, and on other places I'll just put it up as a long video. So have fun. I'll talk to you soon. I'll keep you up to date. I'll show you as we get these things on how everything works. Okay, bye.